This is the video for chapter 2.2 homework. First one is related to question 9, rolling dice. And if you roll 2 dice and add up the sum of those 2 dice, you'll get an answer between between 2 and 12. And so if you roll a dice 100 times, here's what happened. You can see what we call the distribution, how the values are spread out. 8 seems to occur the most. So let's look at some of these questions. What value has the highest frequency? The one with the highest frequency is 8. That means 8 was rolled the most, around 20 times. The lowest frequency is 2, which means here 2 was rolled 2 times, it looks like, 2 or 3 times. The value of 7 was observed 15 times. That's why the height of the bar. That tells you, again, how often it occurred, frequency. The value of 5 was observed 11 times, and you can see 4 is 7. And so then you can kind of see, we can compare this to, it looks like 5 was observed 4 more times, 11 compared to 7. You can see your answer there. And then for part E, what percent of the time did 7 get observed? And that would be 15 out of 100, and that's where we get the decimal value. And if you multiply by 100, or just move the decimal, get very good at that. Don't even multiply, just know you move the decimal twice to give you 15%, okay? And then the important question here is F, is the shape. We talked about in class that the distributions of bar graphs or histograms, there is a shape to them. And here, this one is what we call a symmetric or bell-shaped or normal. It's approximately symmetric or normal. So that's the answers for problem number 9. Moving on to number 12, we're talking about histograms again. And so take a look at their specific shape. This is related to alcohol-related deaths. So take a look at that real quick. Okay, so with histograms, we talk about classes, and which is really what we call the bins, or the different intervals we make to make your bars for the histogram. And so you can see from 0 to 200, 200 to 400. So what's the class width? We can say what you do, we give you a formula, which is you just subtract the lower class limits from each other. And so 200 minus 0 is 200, or we could have done 1,000 minus 800. So there's your class width. That's our answer for A. On B, what are the classes? And so you can see over here the different classes, 0 to 199, 200 to 399, 400 to 599, because this is alcohol-related deaths, fatalities, the number of fatalities. And so you can see here kind of the result of that. So looking at this question, which class has the highest frequency? You can see right here in terms of the highest value is over 30, and that occurs in the class between 0 to 199. And then the next question, what's the distribution or shape of this? And so when we look at shape, remember we have 4 different kind of outcomes right now: bell-shaped or symmetric, skewed right, skewed left, or uniform. In this case, we're skewed right. We're skewed right because the tail of this, right? So there's a graph, and then there's a tail here. There's your tail. The tail is on the right side, so we say skewed right. And then answering this interpretation question, reporter writes the following statement: according to the data, Texas had 1,294 alcohol-related deaths, while Vermont had only 23. So the roads in Vermont are much safer. Explain what is wrong with this statement and how a fair comparison can be made. Well, it does look on the number of deaths, maybe Vermont safer, but because Texas is so much bigger than Vermont, that we would need to somehow compare it to the total number of drivers, the total number of accidents. And so we can see that that would be my explanation, or kind of some interpretation. And you can see there the book gives us some kind of way to do that. There we'd want to somehow look at a proportion or a percent. And so that's what we're kind of looking at here for number 12. So look at problem number 31 now. Same idea again. We have this data here, and what you want to then do is, if 7 classes are to be formed, choose an appropriate lower class limit for the first class and a class width. So looking at these numbers here, it's hard to kind of analyze. What you want to do is we would want to look at the lowest values for this one here. And so again, it could differ. So this is just one answer. So compare it to what you got here. The idea is that this would fit in. So this is an answer just using 0 to 199.9, 200 to 399.9, and so forth. And then you would determine how many fit within here, right? And so that becomes important to kind of recognize that this might not be your answer here. So I just want to make sure you're aware of that. This is an answer for the classes like this. You might have done it some different way, or you might have went to StatCrunch to enter that in and get a different type of answer. And so looking at this here, looking at this data here, if you actually had entered this in, you would then get some values that look like this. So you can get a relative frequency distribution, a frequency distribution. Again, the total before divided by 51 gives you this, and then to get these 26 divided by 51 and so forth. And then here's what the frequency and relative frequency distributions would look like. And again, notice the shapes are identical regardless of its frequency or relative frequency. The important thing is if we want to describe the shape again, what I see is it goes like this, and then you have a tail on the right there. There's your tail. And so from there, you could see this is skewed right. Again, you could have done this on StatCrunch, enter that in. So there are many ways to do this. Make sure you understand the interpretation and the difference between frequency and relative frequency. And I think, oh, there's one more question here. Problem 54 is asking you about the shape, and then you got to get very good at this. And so sketch the 4 histograms, 1 skewed right, 1 skewed left, bell shape. So when you make your histograms, they should have some shape like this. Those are the skewed forms. And again, it has to do with the tails. Here's your right, here's your left tail. Uniform means the same. And here is it's symmetric on both sides. And so just keep that in mind. Here's an explanation here. That's your solutions for 2.2.